Hi, everyone. My presentation is about unit testing channels and flows. It's about how to unit test coroutines. My name is Mohit Sarveiya, and I'm a GDE in Android and Kotlin. And in this presentation, what I'm going to share with you is some examples, simple examples of testing flows, and how do you test errors and delays. We'll also share with you some common testing problems you may encounter. So for this presentation, I will assume that you know a little bit about what coroutines are and a little bit of what channels and flows are, the basics. So how do you go about unit testing, flows? So suppose you had a very simple example where you had an application, an Android app that was communicating with a API. And the API, what it returned, it was modeled using as a stream of data. Suppose it returned an example could be a flow of locations. So we could use a flow to model this stream. So suppose you had a flow which has this type, a flow of location type, for example. Location could be a data class with latitude and longitude. It doesn't really matter. So in your application, one of the benefits of Flow provides the ability to get the data and the stream and to manipulate it with filter, map, flat map to process it. So you may do some of this work in your application depending on your use case. And how do you go about testing this simple flow? So in order to test this flow, the coroutines library provides you with a module. It's a coroutine test module that contains utilities that I'll go over and how they work. So when you include this, you'll include this in your Android application or your backend application. So the first step to writing a test for that simple use case is to first create a coroutine. And to create a coroutine, the first thing that you'll do, you'll use this method, this utility called runBlockingTest. And what this does is that it creates a coroutine for you internally. That's what it does. And inside of this Lambda block, you're going to add your testing logic in there, your actual test, and it will run everything in there inside of a coroutine. So what it does is that runBlockingTest creates a coroutine on a scope. You always need to specify a scope to create a coroutine. So it creates a test scope internally, and it also runs this coroutine on a dispatcher, on a test dispatcher. So everything inside of this coroutine, basically what's run inside of here is what you provide, your actual test that you provide inside of this Lambda block. So how do we go about testing this? The first step is to mock it out using Mockito or some fakes. Have the flow return some actual fake data. So what this will do is that when you collect from it, it will go through the process, the logic that you have in your flat map operations, etc. So next thing is that we want to read from this flow. How do we go about doing that? So the way you do that is one way is to read it into a list. So toList is a terminal operator, one of the terminal operators that a flow has. And what toList does internally is that it takes a flow and it takes each emission and stores it into a list. So it takes the first one, the second one, and the third one until it has read everything from the flow you're testing. And what you could do is that you could take that list and perform assertions on it. So that's a very simple example of writing a unit test. You're testing a flow, basically testing that it goes through the stream and it goes through and performs any logic that you have in your flat map and those two different types of operators. So let's look at basically how runBlockingTest works internally. Go dig a deep dive into how it works internally. So the way runBlockingTest works right now internally is that first thing that it does is it does some setup. So you can look at its logic in 3 different steps: setup, running your test, and then performing some cleanup. So what it does is that it does some setup by creating a scope, and the second thing that it does is runs the tests, everything that you provide, your test body. And when you look at the way it runs it, is that it uses a deferred. So you'll see in here deferred get complete exception or null. That will basically run your test body, and it will catch any exceptions that it encounters and throw in and bubble them up. So the next thing that it does, the next phase of the execution of your test is that it cleans up. And it cleans up any, as you launch coroutines in your test, it attempts to clean up the active jobs. And you can see here, if you have any form of active jobs that are still active, it could throw you an exception. And we'll look at how this could happen, what scenarios this could happen in. So you can look at what this does in 3 different steps that I have specified here. And so this is how runBlockingTest, that's how runBlockingTest works. So when we look at this, is there a better way to collect basically from flows? Is there a better way to basically, give me 1 second. So is there a better way to collect from a flow? So what I'm doing here is using the toList operator.
Sorry, Mohit, you're no longer sharing your screen.
Oh. Well, was that just now or?
Only for like the last like two sentences.
Oh, well, thank God you notified me.
I'll stay here just to verify for you if it's working properly. All right, that looks good. Enjoy.
Okay. All right. So we looked at how does this simple test work. So is there a better way to write this test? So we were collecting from this flow using the toList method. And there's a better way to do this. There's a library by Square, and thank you to Square for creating this library called Turbine that allows that has a fluent API for you that basically allows you to test flows. So the way it works is that it takes any flow that you're trying to test. It takes the emissions in there and it stores them into something called a channel. A channel is like a blocking queue. It's very similar to a subject in RxJava. You could send things to a channel and receive things from it, and it caches. You could also specify it to cache what you send to it. And there are different types of channels which have different types of behavior. There's an unlimited channel. There's a channel which is buffered, which has basically you could specify how much caching, how big the cache should be. There's also a rendezvous channel, which basically you send something to it and it basically waits until someone reads from it. So the way it works is that in an unlimited channel, so it reads basically from your flow and it stores each emission as an event in the channel. So this is the events that are stored in this channel, that something was emitted or there was an error or it completed emitting, the flow completed emitting everything. So when it emits something, for example, some item, it will store in this example an event of some item and encapsulate whatever that was sent. The second time, it will do the same thing. The third time, it will do the same thing. So there are 3 events that are being tracked in this channel. And then everything has been emitted by the flow. So now it needs to add a marker that everything was emitted. And that's basically the completion event. So what you have in the end basically is a record, a history of everything that your flow emitted. And I could query this channel in my test, basically, query these events. So if an exception happened while it was collecting from the flow, it will basically store that as an error event in this channel. So how do we query this channel in our test? Let's look at that. So this library provides you with something called this interface. This interface has methods that you're going to use in your test. And you could determine how long did it take for something to emit, the duration of the emission. You could expect whether were there there may be no events, when nothing was emitted from the flow. You could verify that in your test. If something was emitted, you could also verify using this method. If there was an error, you could use this method right here to determine, to grab the throwable. Lastly, you could verify that the flow completed emitting everything. So this is the interface that Turbine provides that you could use in your test. It makes it really, really fluent when you go to write your test. So how does it work internally? Internally, it basically has a coroutine scope. And in there, it creates a coroutine. It creates a channel that is going to store these events to. It creates another coroutine, a child coroutine, in which it begins to collect from the flow. It begins to read from the flow. So collect is a terminal or another terminal operator of a flow. It starts the flow when you call collect basically on it. If you're familiar with RxJava, it's similar to like unsubscribe. So when every time something's being read, it's stored as an event in this channel. And this right here, as you can see as the parameter, you have access to that interface. So to change our test to use Turbine, I could basically, everything that's going to be emitted, location data, will be stored in this channel, basically, and I'm going to query it. And the way that I'm going to do that is that I'm going to call this method, this extension on the flow, .test, and inside I'm going to do expect item should be equal to location 1. So it grabs the first emission, I'm going to verify it. The second emission, third emission, I'm going to verify those emissions also. Now, how do you verify that the flow has now completed emitting everything? You verify it using this method called expect complete. So now, as you can see, now this is our test using Turbine. And there are really nice safety nets that Turbine provides. So what if basically there was something emitted by the flow in my test, but I forgot to verify it. It will give me an error. Suppose I didn't do expect item and verify the third data that was emitted. It will basically tell me that you are missing basically an assertion that something was emitted by the flow and you didn't do a verification on it. So what if I forgot to verify that the flow actually completed emitting everything? And the way it will give me an exception for that too, that there was a complete event that you basically didn't really do a verification on, that you didn't really query. So these are really nice safety nets that allow you to test, the behavior of flows. So that was how you use Turbine. I want to show you now how do you deal with errors? How do you test errors? So suppose that there's a possibility that when you apply one of these operators, an exception could happen. And what happens when that occurs? So what happens when an exception happens upstream is that the flow will complete. It will complete. If you're using Turbine, what happens is that it has a try and catch internally in which it will basically store an error event basically for you. So here's an example. You can see there's a try and catch while it's collecting, and there's an exception that happened. It will store an error event right there, as you can see there. So if I want to test that scenario, if an exception happens upstream, I could use this method expect error and verify the throwable that it threw something. So, but that's not the best way to handle exceptions, right? Is there a better way to handle exception? There is. So the better way to handle exception is there's an extension called a catch on the flow. So what it does is that if any exception happens upstream, the catch method will catch it, and it allows you to emit something when that happens, when an exception happens upstream. And what it provides you with is this interface called a flow collector. A flow collector has a method to emit something. So what it also gives you is the ability, a throwable, what exception occurred. You could make a decision basically whether you want to emit something or not. So one way to handle this is to use a type that was added in Kotlin called a result type that encapsulates a value, whether it was successful or a failure. So what you could do is that you could update this flow to return some type of a result. And when a catch happened, you could emit something from this flow, result of a failure. Then you could then verify in your test. This is a better way to handle, exceptions with flows. So when exception happens, it will go into the catch block and emit it. And when you go and collect it in that case, you could determine like result is a failure, do some form of logging in your actual code. So when an exception happens, in that case of going to the catch block, what Turbine will do is store an event of an item, basically. It won't be an error in this case because you're handling it in some way in the client code. So what you could do in here is that when you go to test this flow now, you could do expect item is failure, and then you could do verification. Before this test call, you could use Mockito or using some form of fakes, have it so that the flow returns some, have it so that it returns some exception, some error, basically. So that's how you test, errors with flows. The next thing that I want to talk about is delays. So delays are a bit more complicated, and they're the most complex thing in testing flows. And they take practice to understand how it works. And I want to share with you how to handle test delays in suspending methods, in coroutines, and in flows. So let's take a very simple example of a delay in a suspending method. Suppose I have this test right here. I'm launching a coroutine using runBlockingTest, and I'm calling a method, suspending method called processData. Inside of it, there is a delay of a specific time, then I do some form of some other work. So how is this handled, basically, when this suspending method is called? So the way this is handled is that when you look inside of runBlockingTest, what you'll see is that there is this concept of a virtual time. And what you'll see right there is that when it goes, after it has ran, when it goes to run your test, it will attempt to advance this virtual time until it's idle. So what happens is that when this method is called, it will basically begin to execute, go past your delay and continue executing any code that you have after it. So when it reaches this, right, advance until time idle and has performed its operation, then it will auto advance execution forward after this delay, basically. So that's important to know. So how do you now? So if we take that example and make it a little bit more complex, suppose that we didn't have a suspending method, but we were launching a coroutines ourselves and had a delay in it. How do we handle that? So suppose basically you had a coroutine like this, right? I'm launching a coroutine on a scope right here. And inside of this, I have the same logic that I had before. It has a delay and does some execution after it. How do I handle this? So in order to handle this, basically, so the other thing is that, after I call this method processData, I'm also doing some assertion. So when processData method is called, it launches a coroutine, basically launches it, and then it goes ahead and goes ahead and executes more code that you have after it. So how is this handled basically by runBlockingTest? How would this work? So how is this delay handled? So what happens is that when this delay is encountered, this coroutine that's launched, it suspends itself, and it doesn't go forward and execute anything after it. Basically, you could say that it basically hangs. And what happens is that any code that's after this function call begins to execute, and there are some assertions that begin to happen. So basically, how do you control this delay? We don't want this coroutine to suspend itself. I want it to move forward in its execution. So the way that works is that, so when it encounters, the way this test is written right now, the way it will execute is that when it encounters this call right here, advance until idle, at the end of your test, that's when this coroutine here will unsuspend itself and begin execution. And the problem with that is that it has like unintended consequences, right? That's not the behavior I want. Before I perform the assertions, I want this coroutine to go ahead and begin executing, go past this delay. So how do I do that? So the way you do that is by basically, the way you do that is like this. This interface right here is provided by the coroutines library, and what it contains are methods to control what the dispatcher does. You could pause the dispatcher, you could run it, you could execute a piece of code, and while it's paused, basically, and you could advance the time by a specific amount, and that's what we want to do. So I'm going to utilize this interface, this API. And what I'm going to do is that I'm going to say that I want you to advance the time by a certain amount in the coroutine that was suspended. And when that happens, it will basically begin to execute code forward basically, and right after everything that's right after that delay. So what that example does, so this right here, it's important to know, how you use this method to control basically, you could use that method to control delays in your code that you're testing. And when that happens, after you advance this time, virtual time, it will go forward and perform execute any code after this delay. And then you go forward and perform any assertions that you want. So that's how you basically test, delays inside of any coroutines you might launch. So what about flows? And what is the use case for having delays inside of a flow? So the use case is to do retries. So suppose that you were executing some code right here, filter map, flat map, and before it goes to the catch block, I want to do a retry. And retry means that I want to execute the flow upstream again. How do I do that? And there is an extension provided to you called retry, in which you specify how many retries do I want to do. So there's also a retry when you could do a retry based on a certain type of error that you want. So when you do a retry here, you could specify before I want to do a retry, I'm going to delay for a certain time. You could also set this up to do exponential backoff also. So how do you go about testing this? So what this retry will do after that delay is execute everything upstream one more time. So you could also, when you set up this flow, set up to run everything, do the retries on a specific dispatcher. So flow on will execute everything upstream, basically the retry, the flat map filter on a specific dispatcher that you could inject, that you could give it. So how do we test this? So in order to test this, first thing that I'm going to do is that I'm going to create a coroutine using runBlockingTest. I'm going to specify my own dispatcher that I'm going to inject and give to this flow. So that flow setup that I showed you could be some type of a class. The best pattern to follow is to inject a dispatcher in the constructor of the class and give it to the flow. And so I'm going to create this TestCoroutineDispatcher. What I want to do is that I want to have this runBlockingTest coroutine that gets created to run basically this dispatcher that I am creating myself. And so I'm going to inject it in as I showed you, as I explained to you. And in order to have this runBlockingTest use this dispatcher, this coroutine to use this dispatcher, I'm going to use an extension, this extension right here. And what this extension does is that it creates the coroutine, excuse me, with a dispatcher that you supply to it. So then what I'm going to do is tell my flow, hey, begin emitting. It begins to emit, it goes through, flat map, etc. And suppose an exception happens, you mocked it out and trained it in some way. When an exception happens, basically, and it will go into the retry, it will go into this delay. When it goes into the delay, basically, it will, stay there. you need to advance virtual time forward, which is I'm going to do it right here. And then after that, after you advance virtual time, it will go forward and retry everything upstream. And then I could do my assertions. So now, when I advance time, it goes forward, goes upstream again, retries all these different methods. And then you could perform some assertions using expect item, etc. So that's a way to deal with and be able to control delays inside in a test within flows. So dealing with delays is really tricky. What I just explained will take some time practice to get a handle of. The next thing that I want to talk about is how do you test in view models, which is more Android related. How do you test coroutines or in flows inside of a view model? Suppose you had a setup in your Android app, like where you had some activity fragment that was listening to a view model, state updates from a view model. Like this is an MVVM architecture. So, and the view model will expose a stream of states. How do you model that, basically? So to create my view model, I could use Jetpack view model, which has some benefits that it provides, and many benefits. And one of them is that it provides you with the scope that you could launch coroutines on. You don't really have to also use this. You could inject your own scope in, and depends on what you want. So it's interesting. This scope, what makes it special is that it's configured in a way to be lifecycle aware. It uses a supervisor's job, and it also runs on the main dispatcher. So I could launch coroutines. They provide extensions on a view model scope to launch coroutines when in specific lifecycle, basically states. So I'm going to use to expose the stream of states. What am I going to use? I'm going to use a mutable state flow. So recently, what was introduced a couple of months ago or last year was a shared flow and state flow. And there are ways to broadcast to multiple consumers events. And both the state flow and shared flow, what makes them, they all have unique properties. A state flow conflates. And it caches the most recent item you send to it, and if you send something again, it will conflate. And shared flow is different. A shared flow has the ability to replay things. It has that feature. It has the ability to cache and the ability to handle buffer overflow strategies, back pressure. So a state flow is what I'm going to use, and I'm going to specify a default state, which could be loading, for example. And what I'm going to do is that I'm going to launch a coroutine, view model scope that launch when started. And then inside of there, I may have some repository where I tell it to get me some data. And then I tell it basically that I'm going to collect from this repo. And when I get the data back, I'll process it, create the UI state, could be an error or a success, and give it to my UI state flow. So this is how you give something to have something emit. There's also an emit method that you could call on the UI state on the state flow. So how do we test this? So the way you test this is that you can mock out the repository layer in some way or with fake data, and have the view model launch that coroutine. And then I'm going to read from this UI state flow. I'm going to start using Turbine, read from it. And then I'm going to expect, my item, which will be some UI state of success in the happy case of success. And when I run this test, the problem that I'll encounter is that the view model, the coroutine that gets launched by the view model, it's using the main dispatcher. I need to be able to inject in a TestCoroutineDispatcher for it. And there's a utility provided by that. So it uses the main dispatcher. There's a utility that the library provides on a dispatcher call. So there's a set main method. I'm giving it some dispatcher that I have created here. So, and then I could also reset it when the test basically tears down. So what I could do is that I could create a rule. There's a concept of a rule in JUnit, reusable, basically component, reusable piece of logic. I could create this rule that I could apply to all of my tests, in which I set the dispatcher and then release it and clean up. And I could reuse this rule in all of my tests. So I'm going to use this rule just like I did with this annotation here. And then when I run this test, when the view model launches the coroutine, it will be run on the dispatcher and use the one that I made in my rule. And then my test will pass. So this is really a very simple scenario, very simple case of testing the happy path in this setup. If you want to learn more about this, there is I recommend this article, State Flow and Shared Flow, which has an example of it. It has more information on how to also use shared flow. So lastly, I want to talk about some common testing problems that you may encounter, and one of them is this issue here. When you may encounter this common issue that you launch a coroutine in your test or whatever you're testing, and the job is still active. It cannot be cleaned up. And what are the reasons to why that might happen? And the reason why that might happen is because the coroutine was suspended, and it might be because of some delay, and you haven't advanced virtual time forward on the delay. It could also be that you're using, for example, a rendezvous channel, for example, also, or because you're using you called emit on a shared flow, and no one, and when you call emit, the coroutine you call emit from suspends, and there was no subscriber that has read anything. So that's also could happen. And you have to be aware of, you're launching coroutines. What dispatcher are they running on? Are they running on the same dispatcher as your test is running on? Those are things that commonly could happen. So here, let me give you an example. This example, I could also write this example using shared flow. So there's, in this example, I have a rendezvous channel in which I could send events to. I could send and receive an event type from it. When I call send, the coroutine that I call send from will suspend itself until there's or someone reads basically from the channel. So this is a producer, produces events basically on that channel. Here's a consumer that's consuming from the flow, and I'm calling collect from it. So now when I launch this, when I do this inside of runBlockingTest, basically I have a coroutine here. I'm going to call send. When that happens, this runBlockingTest, basically I'm using a rendezvous channel, so this coroutine will suspend itself, this runBlockingTest coroutine, and then you'll get this error. So you'll see is that when you use the debugger, it will basically give a number to all your coroutines that you create. You could specify, something really useful is to specify a name for the coroutine that you have. Libraries do that. gRPC Kotlin library does that. And the name, the coroutine name is a context element. So you could specify the name for a coroutine. And that's useful when you go about debugging things, basically using the debugger. And also here in this exception. So the way you fix this is to basically read from the event like this. So the point of this is not, the point of this is not that I use the rendezvous channels, but why basically this happened, So the other part is that suppose you're testing basically a coroutine and you're using some dispatcher and you have a delay in there. When you look at this test, in here, the way it's set up, the dispatcher that's used in basically the send event is different than the one. There are two dispatchers that are being used. And when it calls dispatcher advanced time until idle, it won't advance virtual time on that same dispatcher. And then you'll get this error that you see right here. Very common error that you'll encounter. And so you could advance virtual time on that dispatcher, go past the delay and give you your desired behavior. So I'm not going to talk about. Okay, so I will skip these slides here because of time. So last thing that I want to say is that I wrote a blog post about everything that I discussed on my website, codingwithmohit.com. And it's on unit testing, delays, and errors. And I give you more examples of what I just shared with you. The other thing is that I started a training program to help people learn coroutines, to share my knowledge. If you're looking for group sessions, if you want me to train, like I could build a curriculum for your company, or if you want one-on-one help, I can help you with that. You could email me to colin.coroutine.training@gmail.com to set up some. We could sync on Zoom or something and I could help you, with training on both backend and on Android. So lastly, here's some resources that I'll have. The other thing that I have that I didn't share as part of my presentation is the testing pattern that's used in the coroutine library itself. It's a multi-platform library. It's a different pattern than I just showed you. There's no run blocking test. It's interesting to see how that's made. It really will help you as you're looking through the source code of the coroutine library. I hope that was helpful to you in learning how to unit test coroutines. And if you have any questions, please let me know, and I'll, thank you. Also, thank you to Android Worldwide for the opportunity to present here once again. Thank you.
All right. Damn, my hair looks crazy. So if everybody just wants to take a moment to write some questions if you have them, then we can get into the Q&A. That was awesome, Mohit. Thank you for putting up with Aramid's
Thank you.
Inconveniences.
So you're right. Expect complete will never succeed on shared flows because shared flows never complete. You're right.
Yeah, there's the whole. I only learned. It was one of those pull your hair out moments, and then I found that there was an issue in Turbine, like that was like a long thread where they defined basically, all right, you got to handle it this way.
Right.
But it might be kind of a good occasion for somebody to put up a PR and contribute here.
Yeah.
I'm thinking about that now. Then comes the question, will you do it? It's a decent thing to do. All right. Anybody have questions you want to put in the Q&A area? Give it another minute. Seems only my question went in there. I'm not even sure my question is a reasonable one to ask. So
I do want to see him sing and dance now. I was just curious how many was watching, how many of you guys and gals use coroutines or flows?
I definitely use it.
Very good.
We can do like one of those reactions for like just another couple seconds while we're waiting. One of those.
Very good. Second person. Got an emoji. Not yet. Not yet. Okay. Do you have any preferred method, or is it different to test combined flows? Well, so you could combine, it's the same method, you could use Turbine, however you set up your stream. So you could combine one flow with the other using there's a combine operator and it's the same thing. It's, there wouldn't be anything different. Interesting, the way how combine works internally has, changed as the version of the library has improved. It used selectors before, and now it does not use selectors. When I started testing, that I had to get into how combine internally works because I had some, issues with how to test it. So to answer your question, it's the same method. You could use Turbine, the .test extension when you call it, it will basically begin to execute, how you have your combine call basically that you have specified. I hope that answers your question well. Anyone have any other questions? Thank you for the heart emojis. The blue heart emojis they're blue.
I mean, I popped the questions area of like, do you know why Turbine is still pre like 1.0?
I don't know. Maybe I don't know. Sorry.
Yeah, I've been trying to figure it out. It's still like pre 1.0, but it's like, isn't this feels particularly stable? Like at this
Let me check what is the version of Turbine. It's been a while since I updated it, and so it is at version 0.41, and I don't know.
I've been like ragging my head. It's like, why can't you just call it 1.0? Like,
Right.
It's got everything I need.
Yeah.
All right, cool. Then I think we'll take a little break for like 10 minutes, and then we'll come back, and Ricken will start his presentation, if that's all right. Thank you so much, Mohit.
Thank you
so much.
Thank you for having me.
All righty, guys. See you in a sec.
See you.